All right, guys. Um, by a quick way of review, I want to deal with y'all are going to do the even problems, and I'm going to do the odd problems. This is from yesterday. We could use the x equals negative b over 2a, but I want you to be able to do it more quickly on the calculator. So we're going to find the vertex and the x-intercepts. So under the y equal menu, if you would type in the equation. Oops, I need to clear that out. All right, x squared plus 8x plus 15. And under y sub 2, make sure you put the 0 because when we do the x-intercepts, we're going to run the intersection program. And to intersect, you have to have two lines. So we're going to go zoom 6 to graph that. Okay, so we can see that, well, depending on what you can see from my screen, I'm a little frustrated. Sometimes it seems to appear, sometimes not. I don't get it. Well, at any rate, there are two x-intercepts that we can see, but first let's get the vertex. So above the trace button in blue is calc. So we go there, second calc. Now that vertex that we just saw was at the bottom, so we're going to use the minimum program. And it wants to establish a left boundary, but I noticed by looking here that the cursor is up on number 15, so I need to either left arrow or down arrow. Okay, see the numbers coming down. There it is. All right. So I need to left arrow it to the left side of that vertex, hit enter. Then I right arrow to get to the right side of that vertex, hit enter. You'll notice if you're doing this on your calculator with me that you've got these two little boundary markers at the top. And when I hit enter the third time, it's going to automatically pick the lowest point between there, which happens to be our vertex. So that's going to be -4, -1. So vertex is -4, -1. Now we're going to find the x-intercepts. And we do that by using the intersection program. So we're already there with the graph. So we go second calc, number 5, the intersection program. And here we move to one intersection or the other, and we hit enter 3 times. 1, 2, 3. So that x-intercept is -3, 0. And the other one, we'll go back to second calc, number 5, intersection, left arrow over, and hit enter 3 times. 1, 2, 3. And that is at, I can't read it, -5, 0. Okay, now number 3 is vertex form, which we learned about yesterday, or hopefully we did. And the vertex, the x value is always the opposite of what's in here, and the y value is always whatever that number is. So in this case, the vertex is going to be at +4, -1. Now to get the x-intercepts, I'm still going to use the calculator like we just did. So go to the y equals menu, clear out that one, and put in, just the way this appears, x minus 4 parentheses squared minus 1. Go zoom 6. And let's do a quick visual to see if the vertex does look like it's at 4, -1, and 1, 2, 3, 4. Sure, that's right on. We've got 2 intercepts, and it looks to me like it's going to be 3, 4, 3, and 5. In fact, a quick way to tell that, rather than use the intersection program, is if it looks to you that it lands right on one of those tick marks, go look at the table, second table. If you can see the 0 there, Sure, here's 3, 0, and 5, 0. So that means those are the x-intercepts, 3, 0, and 5, 0. All right, that was from yesterday, and if y'all would please do 2 and 4 then on your own. Now, number 5. Here we're going to solve by what's called factoring. Factoring is breaking something down to things that are multiplied together. For instance, the number 24 has got several factors, 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Each pair multiplies to get 24. Now, this particular equation is already in what we call factored form. It's this binomial times that binomial gets you 0. Now, once you've got it broken down, and a little bit later we'll break it down, but these are already broken down for us, you use what's called the zero product property. I'd like you to learn that name. What that means is if you've got 2 or more things multiplied that equals 0, one of those things at least has to be 0. They could all be 0, but one of them has to be 0. So to solve this equation using this zero product property, we set each factor and assume that each factor is 0, like so. And then we quickly use a little bit of algebra to solve for m. In this case, we'd add 1 to both sides. So one of the solutions is that m is equal to 1. In this case, we'll add 8 to both sides and then divide by 3. And yes, I'd like you to leave it as fractions. And so that would be the second solution. All right, let's go to number 7. All right, again, we've got one binomial times another binomial. We're going to use the zero product property, set each one equal to 0, and solve them independently. All right, here on the left, we'll subtract 7 from both sides, and then divide that by 2. So one solution is negative 7 halves. This one will add 3 to both sides. The other solution is that x is equal to 3. Now you may be thinking, well, why do you have 2 solutions? Well, if you remember the parabola, very often they cross that x-axis in 2 spots. Each of those x-intercepts is a solution. All right, number 9, same kind of deal. We're going to say 8a plus 3 is equal to 0. 3a minus 4 is equal to 0. Solve them each using the zero product property. So here we'll subtract 3 and divide by 8. So negative 3/8 is one solution. Here we'll add 4 to both sides and then divide by 3. And the other solution is 4/3. All right, I'm going to turn the page now. Again, y'all are doing the even problems on your own, and then you're going to do a practice quiz on this stuff. Okay, again, we've got 2 factors in the equation. We set each one equal to 0 using the zero product property, and this one will subtract 2 from both sides and then divide by 5. So negative 2/5 is one answer. Here we'll add 6 to both sides, and so x equals 6. Okay, now those were all already factored. Now the next set we are going to learn to factor. Now you've had this before as far as I remember, But what we're going to do is anytime you've got a trinomial like 13, 15, 17, 19, it's always going to break down like the ones we just did into a binomial times a binomial. The first term here will be m, because think about that, multiplied m times m, you get m squared. Now, what are the two other numbers? Well, here's the trick. They multiply together to get the C number, which is 16, and add together to get the B number. So what are factors of 16? Well, you got 1 and 16, you got 2 and 8, and you got 4 and 4. Now, is there any of those pairs that also adds up to get to be 10? Sure, it's that pair right there. So m plus 2, m plus 8. Okay, so we've successfully factored. Now we're going to use the zero product property for each of those factors. And so in this case, m is equal to -2, and here m is equal to -8. Not bad. All right, number 15. Now, I will tell you, when you've got negatives involved in these, and you know what, I'm going to do 15 and 16 with y'all. And then probably 19, because 16 is a little bit weird too. But number 20 would be like 16 for y'all, so that'd be a good example. Okay, so we got a trinomial that we want to break down by factoring. So we said a binomial times a binomial. We know the first variable will be k, because when you multiply it back together, k times k is k squared using the distributive property. Now, I want two factors of 36 that if you'll add together, you'll get -12. Well, the only possible way you can do that is to have two negatives multiplied together that would then add and end up being a negative. So let's see what we get. We got -1 and -36. Is that the right pair? -2 and -18. Does that add to get -12? No. How about -3 and -12? No. How about -6 and -6? Aha, bingo. That would be the pair, because they add together to get -12. So we got k minus 6, k minus 6. Set them both equal to 0 using the zero product property. So in this case, k would equal 6, and here k would equal 6. Now, when you have that, which is called a double root, you just list it one time. Honestly, what that looks like is that you've got the parabola that just touches down at that one spot. All right, now I'm going to do 16 with you guys too, because it's a little bit more difficult. But again, we start off the same thing. We've got a binomial times a binomial. And we know the first variable will be n and n. Now, I want two factors of -7 that will add together to get -6. Well, this one is not too hard. First of all, we know that one of them is going to be a positive, one of them is going to be a negative, because multiplied, that's how you get a negative. So is it going to be +1 and -7, or is it going to be -1 and +7? Which of those pairs, when you add them together, you get -6? Well, it would be this one right here, wouldn't it? So that's going to be +1 and -7. Using the zero product property, you got n plus 1 is equal to 0, n minus 7 is equal to 0. So n would equal -1 here, and n would equal +7 there. Okie dokie. So Let's see, do I want to do one more with you guys, or can y'all figure it out? I think y'all can figure the rest of that out. That's pretty straightforward. Yeah, I think that's good enough. Anyhow, hope y'all do well on that. Remember, finish these up, the ones I didn't do. Most of them are the odd. I mean, even some are like 17 and 19. I'd like you to do also, and then do that practice quiz. All right, thank you guys.